Everyone, and thank you for joining us today for this webinar on simplifying change data capture. My name is Parag, and I work as a product marketing manager at Hevo. I'll be your host and moderator for this webinar. Let me introduce you to our today's speaker, who is Nikhil Mishra, who is a senior director engineering at Yahoo. Before we start today's webinar, I would like to remind you of a few things. All attendees will be on listen-only mode. We are going to record this webinar and we'll be sending you the recording post this session. You can type in your questions anytime during the webinar in the Q&A window available on your screen, and we will try to address them one by one at the end of the session. Okay, so before we start the session, let me walk you through our today's agenda. I'll start with a brief introduction to Hevo. Then Nikhil will do the detailed presentation on CDC. Post that, Trilok, who is our product expert, will do a CDC demo using Hevo. And in the end, we will do a Q&A session to address all your questions. Okay, so I will spend a minute here and give you a high-level overview of Hevo. So Hevo is a no-code data pipeline platform that basically connects and loads your data lying across multiple data sources into a data warehouse or a data lake of your choice, such as Redshift, BigQuery, Snowflake, S3, and many more. So we provide 100+ pre-built integrations with different data sources, including database, data warehouses, SaaS applications, SDK, and streaming data services, and many more. The platform supports both ETL and ELT. So Hevo is currently used by customers spanning across 10 different industries and 15 different countries. For more information about Hevo, you can check our website, www.hevodata.com. With this introduction, I'll directly jump on the topic of today's discussion. Before Nikhil starts his presentation, let me give you a quick introduction about him. So Nikhil has over 20 years of experience in DWS domain, and he is currently working as a senior director engineering at Yahoo. He leads the engineering team, and he primarily looks after the media analytics and monetization function at Yahoo. In media analytics, his team is responsible for building massive scale systems to support real-time and historical ad hoc analysis. Whereas in the monetization function, his team is responsible for building monetization features and user experiences on some of the largest sites on the internet, such as yahoo.com and some of his affiliate domains and other media sites. All right. So with this introduction, let's hear Nikhil.
Able to see the screen?
Yes, I can. Perfect.
All right. Hey, everyone, this is Nikhil. We'll just go through a few slides and talk about CDC and data integration. So let's say what's CDC? So, you could define it in multiple ways. This is one definition. So you could use, different arrangement of words and define your own understanding of CDC. But essentially, CDC here means a process to identify changes in a system or a set of systems that you are interested in, changes to which matter to you, to be able to interpret those changes accurately. And then once you understand those changes, you'd want to replicate it, right? The process then to replicate that change to a target system. And when you replicate it to another system, you might have different intentions in mind. You may want to do it for just replication, create another version of the same source data. You may have some other reason. There could be many different use cases of why you would want to listen in and replicate the changes in a specific source system. In your system, in your work area, you may find you are using a database, different instances of a database, or a collection of different platforms. But typically, a CDC environment would something like this. It's in a very simplistic form. There would be a set of source system or a source system. You could have one database, one instance. You could have multiple databases, multiple instances of databases, but using the same platform. You could have file system based data source. You could have APIs. If you're working with third party or within your company, you have different teams exchanging data via APIs. You could have legacy systems, CRPs, cloud-based apps, and different kind of environment. In the middle of it, you'd have a set of processes where you are constantly listening to changes happening into the source system and trying to interpret those, trying to make sense of those, sometimes transforming those, sometimes just using them as is, but essentially moving them over to a destination system. And as we discussed, the intent of that replication could be, an application of that replication could be many. You may want to do that movement of data because you are interested in forensic analysis of this data. I call it historical analysis. Your legal team or the industry you're working in requires you to keep a record of every event or activity happening in your systems, in your source systems, and keep it for audit and compliance purposes. You may want to simply move this data from one database to another database, from one host to another host, or move from one data center to another data center, a region to another region. And again, the reason could be many. It could be high availability, or it could be more about securing the data or making it available in different regions, again, for data ownership needs. You may also use it for a lot of advanced analytics that you may want to use to support your business, for forecasting, for trending, for doing something, some simple linear logical regression on your data set and trying to interpret what could potentially be happening next in your business. So you may have different applications of it. Once you have moved the data over from source systems, brought them together, you could do a lot of interesting things on that data set. Now, when you start the process, and we're going to dig into the middle box a bit and talk a little about it over the next few slides. When you start the process of understanding and capturing change, typically it will begin with enabling CDC. And enabling of CDC may involve the source system itself, or may involve a supplementary system outside of that source system, which would anyways have to integrate with the source system in order to capture change. This could mean enabling. It could simply mean you may set up a slave node or a slave database for your database system. It could mean you may enable aggressive collection of your logs in your source system, where every single action is being logged and made available through a set of files. It may mean increasing or decreasing the history of data that is available in the source system logs, and being able to move those around asynchronously without having to touch the source database by this third systems that may want to replicate the data. But whichever way you go, you would have to first make your source system ready for availability. And this could you may have to work with different teams. You may have to work on your own. But this process is critical. How you enable data collection in your or enable CDC in your source system will have a huge impact on how you are able to, or how efficiently you are able to scale and you're able to collect your data. Once you enable change data capture, the next step would be to be able to collect those change. And in that process, you'd be simply looking at and listening to all the changes that are happening to the source system, and you'd be constantly reading that data, and you could be either transforming those, or you'd be deciding to simply annotate a little bit and send it to a destination system. But essentially, here is where you'd be, the job here would be primarily to collect all the data reliably, securely, and make it ready for transferring to a destination system. Once you've collected the data, you may want to ship it around. And when you ship it around, there could be one or many target systems where you may want to move the data. And again, the needs will be different in different scenarios, but you will have to define how you're going to deliver this data. And based on that, your serialization format, your end structure could be different depending upon how the destination system is going to be used. If it's a simple application of it, you may not need to do a lot of changes to the data structure. But if it's for analytics and some of the advanced analysis you may want to do on the system, or if it is for audit and compliance reasons, which will require more annotations and details on each of the data set, you may have to do a few changes in your source data set. And once you have defined your target, obviously you would need the entire data set to be available over there. You're not interested in a data set where you have partial availability, where you have data set available from a point in time, but you may want to begin with the entire history of data. So when you define your target and when you do the load, you would be doing the entire snapshot or copy of the data at once. And from there on, you would start doing an incremental refresh of data typically. And there could be scenarios where you may want to do, you may have to do a full copy once in a while. And that, typically you would do that if the incremental load is not considered very reliable in your environment. There are many methods with which you can implement CDC. This is by no means comprehensive list of ways you can implement change data capture, but these are some of the widely used methods that you'll find in the industry. At the simplest level, you would have things like database triggers, and most databases support this kind of capability natively. And here you'd be using database native capability to understand all the changes happening to a table, to a data set. And once those events are fired, you could define your logic of what you want to do with those events. You could also use other methods like you can introduce timestamps in all your tables where it tracks when the rows were modified. You could, if you are in a business with online presence or mobile applications, you may be dealing with logs. You may implement change data capture using that route. You may have a lot of different systems which are pretty sophisticated, and you work with them, and they have a pretty robust integration available for data exchange. And you may directly decide to directly integrate with those systems and simply leverage those capabilities of change data capture, data exchange that they might provide. You may also use, on the database side, again, you may use their capabilities, and this could be relevant for the traditional RDBMS systems as well as modern NoSQL databases, where you would tap into the log files, which it could be change logs, it could be redo logs, it could be bin logs, it could be log files available within the database natively, asynchronously, allowing you to collect that data and transfer it over to your destination system. You could also have a pub/sub-based system. This is widely popular lately amongst a lot of complex big data systems, where you could have all your source systems publish the data in a specific serialization format on a queue, on a bus, where a lot of other systems who are consumers of this data, who are interested in this data, may just come and consume it in the same standardized format and replicate in the destination system. We'll talk about each one of those briefly in the subsequent slides. If we talk about DB triggers, it would simply be a very well-known DML, DML trigger methods that you may have in your databases. You would enable those, and you would start listening to those events and take actions based on that. Now, this provides for a very good integration with database and native integration, almost near real-time capture of change events, and gives you a lot of granular control over how you may want to replicate your changes. Now, when you enable trigger, you would also know that you could end up introducing overrides every time. Now that a DML is fired on the database, requires the system to also do something else, something more. And depending upon the complexity of the logic and depending upon the number of actions you take in these triggers, you could be introducing quite a bit of overhead to your environment. This is synchronous, and this could obviously have an impact on the applications that are directly relying on this database and depend on this database for user experience, for capturing transactions, be it online, be it through an application within the company. But it could have an impact on the performance of the system and how the user experience and response time is. This method obviously requires coordination between two teams. Typically, you would have a DBA team that is managing your databases, and they would be very much interested in things that are happening inside the database, and that could have an impact on user experience. So you would be constantly coordinating, and hopefully you'll be constantly coordinating with your DBA team and keeping them up to date on what kind of application you're building on top of your change data capture. So this method, even though it's very quick to implement, very easy to go ahead and take control of all your changes and move it around or take action the way you like it. It does have quite a bit of things to worry about and take care of. DB modification timestamp would be the other method you may want to use in the database. Gives a little bit more control to the development team, where this becomes this falls squarely on the application development side of things, where you define your schema in a way that captures changes to specific logs and just stamps those rows with a timestamp that indicates how long will it take, when was the row last touched, and you may decide to use this metadata to identify the rows that change after a certain point in time, so that you can identify those rows and move them around. Now, this gives you a lot of ability because the purpose of adding this metadata is to identify those rows. And once you identified that rows, it's completely within the application what you may want to do. And you can make it as complex as you want, or you can add a lot of transformation and business logic in it. You could annotate it the way you want. You could decorate each event with additional fields you may want, and this will typically not block the transactions. You are doing it separately, but again, it could have an impact depending upon how much data you are reading at a time and what you are doing, and how much load it's putting on the system. So there is some amount of impact, but still not a blocking, blocking call to your database environment within the same transactions. In that sense, it's asynchronous compared to the DB triggers, but still has or could potentially impact the performance of your system. Again, there could be some challenges here. You could decide to introduce concepts of soft delete in your system, but still you will have to handle your deleted rows a little more carefully. And depending upon the scale of the system, this could have its own implications. And depending upon the kind of transactions that are happening in the system, this could have its own problems. And if you have massive scale environment, and massive scale depends upon it's not just about the number of rows, it also depends upon your own hardware footprint. So, your database or your hosts are configured to handle certain amount of load. And if you exceed those, and that's very, very much possible depending upon how ETL is set up, depending upon how the change data capture process is set up. And this could have an implication on the performance and response time of your database. Timestamp event logs. This is again, as I said, it's very typical in web applications, in places where you could have native apps. And what you want to do is capture all the activities that are happening on your sites and make it available for downstream systems to consume. You could do it by way of constantly streaming your logs and all the events from it to your environment. You could do it by collecting timestamp based files on your server logs and move them around, collect them and process them. Now, the positive is you're not relying, so you may have underlying MySQL database sitting somewhere, but you may decide to log those events or ship those events into the logs, or capture those events within the logs. And that way, the CDC system need not go and rely on your database or read your database for all those changes. So the two systems are separated and are designed to scale for their own needs. This kind of setup could be highly scalable depending upon the underlying platform that you decide to use. You can go from a few hundred events with simple single server setup to billions of events with massive cluster setups with multiple commodity nodes or big data environments. The negatives here are that you need to understand every single transaction, and if you use a web log or a server log for capturing everything in your everything that's happening in your environment, then you could understand that the kind of events that will flow in would be very different. The kind of transactions that happen in the database would be very different from the kind of activities happening on the website. You may want to capture each of your DOM module. You may want to capture each of the transactions, core actions that are taken by the users. You may need to understand each of the events that are happening. You may have to be aware of the vagaries of data exchange on the internet. And you need to implement a lot of guardrails to ensure that you are collecting the data reliably and are understanding it well enough and doing all your transformations based on your understanding of the underlying data. It's also very different in the sense that it's not you won't typically find a database engineer comfortably transitioning into an environment like this. This will require a very different kind of mindset to integrate in your system and to be able to leverage this kind of a setup for your analytics needs, for your compliance needs, or anything else you may have. Direct app integration, again, this is something that a lot of applications and a lot of systems provide. This direct integration could be via a set of APIs, or it could be via a set of connectors that are made available by some of the systems. Now, given that these are one-to-one connections, one-to-one direct integration, there's a lot of things you can customize, a lot of things you can change. The challenge here would be depending upon how many such systems you are using, things could get really complex. So if you are in an environment where you are using one tool as a for a CRM, another tool for your sales, another tool for your HR purposes, you would understand how complex things will start becoming if you have to integrate with each of the system on their own and try to understand each one of them and bring the data in and make it available for your end use. So this could, it's very easy as you start off and implement it for a single system environment, but you, just like everything else in CDC, you have to take into account the end state environment that you'll be operating in. And if it's going to get complex, it's going to get more and more crowded, then you have to be a little more thoughtful in how you integrate with the systems. Log-based CDCs, again, could be for RDBMS environment, could be for NoSQL environment, but essentially you'd be again tapping into your database capabilities, and these are mostly available in all major environments as capabilities that you could use or leverage for your change data capture. So here, instead of relying on the tables itself, on the tables whether through a column or through a trigger, you'd be doing this asynchronously and leveraging the logs that are available in this environments to asynchronously read those changes and use them for your CDC environment. Now, this could be a ready log in something like Oracle. It could be bin logs in MySQL. It could be change logs in some NoSQL environment. But essentially, you'd be tapping on the logs files that these databases create, and they themselves capture all these different events or activities that are happening in their environment. So in a way, it gives you a lot of reliability that all your events would be captured, because the systems cannot, they use it for eventual consistency of their database, and obviously they need to capture and sequence each of the events as they happen in order to operate. Since you are leveraging the native capabilities, you can rest assured that you'd be best positioned to capture all the changes. You don't have to worry about how to capture those changes. It's about more how to consume those and use that for your environment. Highly scalable. You could, the scale of this would depend upon, again, the kind of hardware you're able to deploy for your environment. You can obviously customize it. You have the data at single transaction granularity. You can do whatever you want with it. But like anything with this kind of capabilities, this also comes with the challenge of, this is not trivial. You need to understand the log structure for each of your databases in your environment. And these structures are prone to change, and they could change incrementally. They could change dramatically depending upon the version of the product that you're using. And these are driven by the needs of the database, not necessarily by the need of your change data capture strategy or other, or CDC strategy of other consumers of that product, because this would be internal logs that the system would be using, and the team would change it the way they see fit for their own optimized use. So you'll have to when you begin, you'll have to understand it pretty well. Not only understand it for the first time, but you need to constantly stay on top of all the changes that are happening on those underlying logs and the format, and be able to learn. This is, again, as I said, it's not something that lends itself pretty obviously to database engineers who are working with databases, who are used to this. Is a completely different way of consuming data from your database. You will be, once you master it, obviously, you'll be able to scale it. So that would not be a problem, but your scaling would be largely depending, will depend on, or would be more about understanding how the logs are for different environments and different databases in your system. Now, PubSub-based CDC, now this is a very popular way, or has been recently very popular way of doing this thing. This requires work both at the source and the destination layer, but it's a way of decoupling the two environments. So in this case, what you would typically do is, you would introduce a platform piece where everybody in the company can go and write data to, and can also read data from. And examples of this would be things like Kinesis, things like Kafka, or Google PubSub, or environments where you basically can go and write both in real time and in batch processing or micro batch process. That you should be able to write it down as a set of topics or tracks, and make it available for everybody in the company to use. So typically in an environment like this, you would have that platform backed by a team that is responsible for data governance and data architecture, who would define not only the serialization format, but the schema, the model that should be used to publish data into this onto this platform. And and all the source systems that that are needed eventually in the CDC environment would be asked to write their data or write the changes to their data to a platform like this. And this allows for destination systems to not having to worry about talking to each of the source systems and understand each of the source systems. It's the responsibility of the source systems to capture the data, and those teams will write it over to this PubSub based model. And once those are available there, the platform team could again define the retention period, how long the data would be retained, how big the configuration should look like in order to retain that kind of data. And once they published it, the consuming system could go ahead and start consuming it based on the published data model, based upon the availability of the data, based on their need. And this way, everything is essential for the destination system to use for the need. Now, if you look at this is a reference architectural pattern that you would typically see. You have a set of source systems, you have RDMLs, you have files, you have APIs. You could publish the data in a streaming fashion constantly. Each change flows in. You can have it in batch data, where you pick up your data in batches, in small batches or big batches, and move them around through a publishing PubSub layer, and different destination layers could just consume from that and use it for their own need. So you could have this architecture, you could have different architecture, but essentially it will have some variation of system where the CDC environment is enabling exchange of data between the two systems. So that kind of wraps up this conversation. I will hand over back to Parag, and let's go from here.
Yes, thank you so much, Nikhil, for this insightful presentation. All right, so I will now ask Trilok to do the demo of CDC using Hevo.
Right. I guess you're able to see my screen, right?
Yes.
Great. Thank you, Nikhil, and hello, everybody. So I'll be giving a short demo on the CDC capabilities of the Hevo application. So for this, let's start by creating a data pipeline. And so as Nikhil was mentioning that there are different ways of doing CDC, achieving CDC. In this demo, I'll be taking two data sources. Although Hevo is capable of providing CDC capability on all of the data sources that it can read from, I'm just going to pick two of these for the demo. So let's start with the relational database MySQL. In this, Hevo provides two modes of CDC. One is based on logs, binary logs in this case, and the second one is based on modification timestamp columns. So let's go with the modification timestamp based column in this case. So I select this table mode, and I need to provide the credentials of my source. I'm going to use a pre-configured source. I'll name this pipeline as CDC. And in this next screen, you will see that Hevo tries to find all the tables in the database and what are the best possible modes of loading data from. So I select one of the tables, and in this, Hevo has automatically detected that updated_ts is the timestamp column using which we will be performing the CDC. I choose Redshift as my destination, again a pre-configured destination that I've already created. And on this screen, I am able to configure how the source table's schema maps to the schema of the destination table. And this is all it takes to create my data pipeline. And there are a couple of things to note on this page, that this is the table that we wanted to perform CDC on. And the position that you see over here is the updated timestamp column of the latest, most recently updated record that Hevo has read so far. So for the first time, when the pipeline starts, it ingests all of the data starting from the beginning of time. And subsequently, it is going to read only the data that is changed. So I'll go ahead and change one of the rows in my table. And let's see how Hevo behaves in this case. So the second thing is the ingestion frequency. So this is the frequency at which Hevo polls data actively. I'm going to trigger a run manually so that we're able to quickly fetch the data this time. So as you see over here, now this time Hevo has read data up to this updated timestamp, which is 2038 IST. And if you see the total event counts, that has gone up only by 1, which reflects that it's only the change row that was ingested. So in the second example, I want to show the CDC that is provided for non-database source. Let's take Google Cloud Storage, for instance. So for the benefit of people who are not aware of this, this is an online cloud-based file storage system provided by Google Cloud. So I need to provide my credentials for the Google account, which I have configured already. The next step is to specify the details of the bucket where my data is present. So this is the bucket. I have created a folder people in that, and there are 2 files in this right now. One second. Yeah, so I'm going to create my pipeline here. And I know that the data that I have is in JSON format. This time I select a pre-configured MySQL database as my destination, and I create my pipeline. So it takes a couple of seconds for data to begin ingesting. And I'll go to the file log over here, which indicates the files that have been read by Hevo. So as we see over here, 2 files have been read by Hevo so far, which is all the files that we had in the bucket to start with. And we see that a total of 10 records have been created. Now I'm going to go and add one more file to this bucket and see how Hevo behaves. So this file is present in my bucket now. And I'm going to trigger a run of this pipeline again, although it automatically ingests every 5 minutes. And this 5 minutes is also configurable depending on the amount of changes that you expect to see in your data sources. So this time, you see that only one of the most recently added file got read. And that also reflects in the fact that 6 more records were added, while in the first run, 10 records were added. So for the first time, it reads everything that is there in the data source. And from the next time onwards, it reads only what has changed or what has been added incrementally. All right, so this was what I had in short with respect to the CDC capabilities of Hevo. I think I'll hand over the stage to Parag, right?
Yeah, thanks, Trilok, for this demo. Now, okay, let me share my screen. Okay, now it's time for Q&A. We don't have much time left for this, so we'll take 1 or maximum 2 questions. So let me read some of the questions that we have received from the attendees. So first question is, okay, can we ingest change data in real time, or there will be still some lag in it? So Nikhil, would you like to answer that?
Sure. So, so change data, you could, I mean, real time is always subjective. You don't necessarily think of real time as immediate. So there will be some lag, and the lag should be in the order of milliseconds. It could be in the order of seconds. There will always be slight lag. So you typically use the word near real time, and depending upon what is that need of near real time, you would configure your system that way. We do process data in a streaming fashion where the data is available near real time. I could give examples of some systems that we have built which have a lag of 1 second or under. We still commit our SLA to about 5 seconds or so, and that's acceptable to the user that is consuming that data. So yes, you can build the data in near real time. How real time is it is, and how you would want to configure it depends upon the use case. And you could do it from a lag of under a second to a lag of under a minute, and all of them provide their own advantages and challenges, and you can take a call based on that. The more real time you go, the more unreliable you could become at specific point in time. And the more you slow down, it could be slowing down by a few seconds or by tens of seconds. You can make it more reliable, but that would also introduce a delay. So it all depends upon your use case, but yes, you should be able to process your data in near real time and make it available for analysis.
All right. So we'll take one last question. And this question is, how are the failed events handled in CDC?
Okay, thanks. So I'll give an example on how Hevo does it. So every time there's an incompatibility in the data that comes in with respect to how it should be written to the destination, it is parked in a temporary storage area, similar to the fashion how Nikhil was talking about, that there's a asynchronous system in between. Hevo also has an asynchronous system in between, which has a capability of parking those events that have failed. And next time when be it bugs or be it interventions from the user that are required, appropriate actions can be taken, and then these events can be brought back into the pipeline and then moved to the destination. With respect to failures while reading from the source itself, so Hevo again tries different modes of ingesting data. So if, for example, if there's a limit to how much one of the modes can ingest, the customers can choose to move to a different mode in which they should be able to say ingest all of the data that is necessary. Nikhil, do you want to add anything there?
I think that's fairly well captured. I think that's good.
All right. So I think we'll move on with this Q&A session, and talking about our next webinar, we are doing the webinar on selecting the right data warehouse, which is on 25th June at 9 a.m. Pacific time. So you will anyways receive an email from my side, and you can also check our website for more details and register there. So with this, I would like to thank all the attendees for joining us today, and special thanks to Nikhil and Trilok for sharing his knowledge and experience with all of us. If you are interested in knowing more about Hevo or want to schedule a demo with our product expert, then please visit our website www.hevodata.com. You can also sign up for a free trial there. If you have any questions or feedback about this webinar, then please write to me on parag@hevodata.com. See you for our next webinar. Till then, take care and stay safe.